Okay, so today I'm going to talk to you about the chemistry behind permanent waving. So it all starts with the bonds in the hair. So we know that we have hydrogen bonds that are very weak, easily broken with water and heat. These bonds will be broken as we wrap the hair, so there'll be a physical change that happens. There's also the disulfide bonds that are going to be broken during the permanent wave process. So the disulfide bonds, those are the really strong bonds. Those are the chemical bonds. Those are the ones that are broken when you apply chemicals to the hair. And then there's salt bonds, and that they break when there's a change in the pH of the hair. So, but with this chemical action that's going to happen, we're going to talk about the chemical bonds, which are the disulfide bonds. So the first thing that's going to happen when you do a perm, you get it all wrapped, it's ready to go, you're going to take your waving lotion. Waving lotion contains hydrogen. When the waving lotion is applied to the hair, here are my sulfur. So this is my disulfide bond. Write that on here. This is my disulfide bond. When the waving lotion is applied to the hair, the hydrogen is released. When hydrogen enters, sulfur apparently really likes hydrogen. So what it does is it breaks apart. So this disulfide bond separates. So those two sulfur atoms now, they're on their own and they're heading towards hydrogen. So now they connect with a hydrogen bond. So now instead of it being a disulfide bond, we have a sulfur atom with a hydrogen atom. When these come together, this is what allows the perm to do what it needs to do. So it's going to allow the hair to actually change shape. So we're changing the chemistry, we're changing those bonds that are within the hair. So this chemical action is called reduction. The cool name is redox. So it's when the disulfide bond is broken by the hydrogen that's released from our waving lotion. It connects to the hydrogen, and now we have a sulfur and a hydrogen that are floating around and they're forming into this new curly shape. So that's reduction. Now it can't just stay like that because the disulfide bonds, they're the strength. Those are those really strong bonds in our hair, and we need to get them back together again. So when the perm is all finished processing, then we go into the neutralizer. The neutralizer contains hydrogen peroxide. Hydrogen peroxide creates the chemical action oxidation. So when the neutralizer is applied to the hair, the sulfur that's with the hydrogen, they're hanging out, they're reforming the shape of the hair, but now oxygen is released into the hair. Now what sulfur is unaware that's about to happen is hydrogen, even more than it likes sulfur, it really likes oxygen. So the hydrogen releases itself, so this is going to break. It releases itself from the sulfur and it joins to the oxygen. In fact, two hydrogen will join to one oxygen. And if you're familiar with some chemistry, two hydrogen and one oxygen creates H2O, otherwise known as water, which eventually is just going to get rinsed out of the hair. So we have reduction or redox. This is what's going to cause the hair to actually change its shape. So the disulfide bond is broken because of the hydrogen that's released in the hair. The sulfur connects to the hydrogen, and now it's changing the shape of the hair. Next, the neutralizer comes on the scene, which has hydrogen peroxide, so it has oxygen in it. Hydrogen now really wants to be with the oxygen. It separates from the sulfur and joins up with our hydrogen, creating water, which then gets rinsed out from the hair. So when this happens, the sulfur, they find each other again. And when they find each other again, everything is well in the universe. So that's basically, in a nutshell, that is the chemical or the chemistry behind permanent waving. The two processes, reduction or redox and oxidation. Thanks, guys.